4.7, solving problems with quadratic functions. Now here is going to be a whole set of word problems. So there are a few steps that we can make, and we can kind of use that as a checklist. So if you wanted to rewrite these steps or create a mnemonic, okay, or create something that will remind you of the steps using letters from the steps to create something that you'll remember, that's great. But here are the main steps. Set up your variables. Sometimes we need to draw a diagram to help us out. And sometimes we can use a table of values. We can set up the quadratic function from the data that we obtain from these two things, and then what you want to do is complete the square. You don't always have to, but as long as you find the vertex, and I don't give explicit instructions, you can use the y value, or sorry, the x value of the vertex is negative b over 2a, okay, and then sub to get y. But usually completing the square is going to be our best option. The first one that I'm going to do, I'm actually not going to do completing the square, and I'll show you how, but the remaining I will. So when you complete the square and find the vertex, the y value is the maximum or minimum. Remember, if there's a negative a, so if a is less than 0, you have a quadratic that opens down, so you get a max. And if a is greater than 0, you have a quadratic that opens up, so you have a minimum at your vertex. So y is the maximum or minimum, and x is when it reaches the maximum or minimum. So x is your independent, and y is your dependent variable. So let's just go through this first one. Remember, I'm not going to complete the square for this one because it actually gives us a really nice form that we don't have to. So Frank has 50 meters of fencing to enclose a rectangular area. So I'm just going to draw the diagram, okay? And if I say length and width, find the maximum area that can be enclosed. What are the dimensions? So I'm going to say length and width, and I'm going to say L equals length. So this is step number 1. L equals length, W equals width, and A equals area, which is maximized. So if I were to write an equation, I would say L plus W plus L plus W equals 50. If I were to simplify that, I would say 2L plus 2W equals 50. And now what I can do is I can divide all 3 by 2 because each of the 3 terms, so on this side we have 2 terms, and on this side of the equation we just have 1 term. So we're going to divide everything by 2, so I say length plus width equals 25. And we're going to use this. Now, what is really important with these word problems is that you only have 2 variables. If I were to say area equals length times width, that's not super helpful because it doesn't tell us the relationship between these 2 things. So what I'm going to do is I'm actually going to put W in terms of length. So we can say or W equals, and I'm going to subtract L from both sides, 25 minus L. So instead of putting my W in, I'm going to put this expression. So I'm going to say area equals length times width, which is 25 minus length. So it's pretty easy. So I just want to highlight a few things. this is our dependent, so this is like our y. And the L is like our x. So this is our dependent, and this is our independent. So when we want to get, when we want to find out what the axis of symmetry for this is, because I'm going to use what we know to find the x-coordinates of the vertex, or in this case, the L-coordinates of the vertex. So we're going to say the L-coordinates of the vertex. We're going to say it's usually x1 plus x2 over 2, but we don't have x's. So the L-intercept is going to be L1 plus L2 divided by 2. Now, just by looking at this, when we set our a equal to 0, which is like our y, I say 0 equals L 25 minus L. So I know that my two L-intercepts are going to be 0 plus 25 divided by 2. So the L-coordinates of the vertex are actually going to be 12.5. And this makes sense. It's okay for something to be to have the length of 12.5. So we don't have to do any rounding either way. So now to find the A coordinates of the vertex. Now this is going to give us our maximized area. That is, we're going to find A when L is 12.5. So we're going to say 12.5 times 25 minus 12.5, which is 12.5 times 12.5. So the area is going to be, the maximized area is going to be 156.25 meters squared. So our vertex happens at 12.5, comma, 156.25. So this tells us the dimensions, or our length, when the area is maximized. And this tells us our maximum area. So let's look at the question again. Find the maximum area. So I'm going to use a different color that I haven't used. Yeah, I think I have that. So find the maximum area that can be enclosed. Well, my friends, this is the maximum area that can be enclosed. And what are the dimensions? Well, we know that L equals 12.5, and width is just 25 minus 12.5, which means that width equals 12.5 as well. So we have this square that is 12.5 by 12.5. So when we are looking for the dimensions, we're saying that the dimensions are now going to be 12.5 and 12.5. And I would have given myself half a mark off because I forgot something. I forgot my units, so meters and meters. So if I wanted to write a final statement, I would say maximum area is 156.25 meters squared. Put a box around it because I like my teacher. And dimensions they're going to be length equals 12.5 meters and width equals 12.5 meters